You've probably asked a chatbot a question, right? But have you ever stopped to wonder how it actually learned not just what to say, but how to say it? I mean, how did it go from being a raw brain that just predicts the next word to becoming a helpful, almost conversational assistant?
Okay, so here's what we're going to dive into. First, we'll get a handle on the basic problem, how an AI makes that leap from just being a text predictor to a useful assistant. Then we're going to walk through the 3 main pathways that get it there, teaching it to follow instructions, helping it learn what we like, and a new, more direct route. And finally, we'll zoom out and look at this whole alignment journey.
So, let's start at the beginning. Imagine a freshly trained AI. It's basically read the entire internet. It's full of facts, it knows grammar inside and out, but it has, well, 0 social skills. Its one and only goal is to predict the very next word in any given sentence. And this whole next token prediction thing, it's incredibly powerful. It's how the model learns about everything from history to physics. The problem is, it doesn't teach it how to be a useful assistant. It learns to continue a pattern, not how to actually follow an instruction.
So what do you think happens when you give a simple instruction like this to that raw AI brain? You'd expect a nice, simple answer, right? Well, what you get is not quite what you'd hope for.
And here we go. Look at the difference here. The raw model on the left, it just continues the pattern of the prompt by listing more things to explain. But the helpful assistant on the right, it actually answers the question. And that gap right there between mimicking and understanding, that is the core challenge of AI alignment.
So how do we fix that? How do we bridge that gap? Well, the first pathway is the most common sense approach you can imagine. You just show the AI exactly what a good answer looks like, over and over again.
Think of it like giving the AI a giant stack of flashcards. On one side, there's a question, and on the other, a perfect human-written answer. After seeing thousands upon thousands of these, the model starts to learn the format of what it means to be a helpful assistant.
Now, this method definitely gets us part of the way there. It teaches the AI how to answer questions correctly. But it starts to run into some pretty big problems, especially when things get a bit more creative or subjective. So the bottom line is that this method, SFT, is a great start for teaching the format, but it's just too rigid for anything creative. It's expensive to make all those flashcards, and pretty soon the AI actually gets better than its human teachers. This bottleneck meant we needed a smarter, more flexible way to teach it. And this leads to a real breakthrough idea. What if, instead of trying to show the AI a single correct answer, we could teach it to understand what humans prefer? What makes one answer just feel better than another? I mean, think about it. It's kind of hard to rate an answer on a scale of 1 to 10. Is this a 7 or an 8? Who knows? But it's incredibly easy to look at 2 answers and just pick the one you like more. And this simple, natural human skill is the key to the whole thing. Look at this example. It's perfect. One summary is totally irrelevant. The other is concise and helpful. The choice is obvious. By collecting millions of these simple human choices, we can build this massive, powerful data set of our preferences. We're not teaching it what's correct, we're teaching it what's better.
This whole process has a name you've probably heard, reinforcement learning from human feedback, or RLHF. It's a powerful but pretty complex 3-step dance. First, you train a totally separate AI to be a judge that learns human taste. Then, you use that judge to coach the main AI, giving it a little reward every time it generates an answer that the judge would like.
And the results? They were absolutely stunning. This was the first time a method allowed an AI to generate summaries that people actually preferred, even over summaries written by other people. It was a huge leap forward in making AI genuinely helpful. But here's the catch. RLHF is incredibly powerful, but it's also kind of like building an entire factory just to bake a single cake. It's complicated, it's expensive, and it's hard to get right. And all that complexity led researchers to ask a really brilliant and simple question. So let's explore that question. This brings us to the third, and maybe the most elegant pathway of them all, a method that tries to get those same amazing results without all the complicated machinery.
This question is really the heart of it all. Why can't we just skip the middleman? Why not go straight from the human preferences to teaching the language model what to do? This idea led to a new method, direct preference optimization, or DPO.
At its core, DPO is a clever mathematical trick that rephrases the entire problem. Instead of that complex, 3-stage pipeline, it turns alignment into a simple classification task.
Just increase the probability of generating the winning answer and decrease the probability of generating the losing one. That's it.
It's just one simple, elegant step. And because it's so much simpler, it's also way faster and cheaper. It's really no surprise that DPO has been picked up by so many open-source models, like Llama and Mistral, that need to be as efficient as possible. Okay, so we've walked through the 3 main pathways that turn a raw bucket of text-predicting bolts into a helpful assistant. But what does this all mean for the AI that you and I interact with every day? So here's a quick recap of our journey. We started with the simple flashcard method, SFT. Then we moved to the super powerful but complex RLHF. And finally, we landed on the elegant and efficient DPO. Each one was an innovation, trying to find the perfect balance between being simple and being effective.
Now, what's really fascinating is that this alignment journey doesn't just make the AI more factually correct, it literally changes its personality. The model learns that we as humans prefer answers that are well-formatted, a bit more detailed, and even a little more cautious. A whole conversational style just emerges from our collective preferences.
But, and this is a really big but, this creates its own set of challenges. When you optimize something so heavily just for what we like, you can create models that are, well, sycophantic. They become too eager to please. They might agree with bad ideas just to be agreeable, and that can be really unhelpful or even dangerous.
So, the next time you chat with an AI, you'll know about the hidden pathways it traveled, from being a raw text predictor to a conversationalist literally shaped by our tastes. We've figured out how to make AI helpful, but the journey is far from over. And it leaves us with a really important question. In teaching AI to please us, are we accidentally preventing it from telling us what we actually need to hear?